Hello guys, you are welcome to this lesson. Today our focus is going to be on trigonometry, and so we'll be concentrating on trigonometry lesson 1. Okay, so when you look at what we have over here, anytime we are dealing with trigonometry, then the right angle triangle is very important, and knowing the size is very important. And so the first thing we are going to look at is knowing the sides of a right angle triangle. Okay, so when we say a right angle triangle, this is a triangle with one of the angles being 90 degrees, whilst the other two angles are acute angles. What I mean by acute angle is that it means it is less than 90 degrees. Okay, so when we take this diagram into consideration, as we have it over here, this is 90 degrees, and alpha over here is less than 90, and beta over here is also less than 90. When we have a triangle like this, then we call it right angle triangle. Now they have the sides. Okay, so now let's look at the sides of a right angle triangle. We have BC, we have AB, and we have AC. Okay, now for BC, we call BC hypotenuse. Okay, BC over here is hypotenuse. The longest side of a right angle triangle is called the hypotenuse. Okay, so BC, there's no any argument about BC. BC is the longest side, and so we call it hypotenuse. Now, with respect to AC and AB, we do not have any specific name for them except with respect to the angle that we are looking at. Okay, so with respect to angle alpha, okay, so with respect to angle alpha over here, our AB. AB will represent the opposite. Okay, it is opposite the angle we call alpha. So AB will be opposite. That is with respect to alpha. Okay, so our AB will be opposite. Then the other one will be the adjacent. So our AC will be the adjacent. So AC is adjacent. Now let's come to beta. With respect to beta, okay, so beta, our BC certainly is still hypotenuse. Hypotenuse. Then our AB, now let's look at our AB. Our AB, first of all, with respect to angle beta, you can see that the opposite will be AC. So opposite the angle beta will be AC. Okay, so our AC is now opposite. Our AC is now opposite. Then the other one, which is the AB, will be the adjacent. 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 So clearly, our opposite and adjacent, we don't have a specific side that we will call opposite or adjacent, but it is with respect to the angle that we are referring to. Okay, so as you can see in this diagram, you see that when we have alpha, one side will be opposite, the other side will be adjacent. When we have beta, then they will interchange. Okay, so that is what we have for the sides of right angle triangle. Okay, so this is very important, and you need to take note of what we have over here, because going forward this is going to help us in solving questions involving right angle triangle and trigonometry. Okay, the next thing that we are going to consider is what we call Pythagoras theorem. Pythagoras theorem. Okay, and what does the theorem say? Okay, so with right angle triangle, if you are given two sides, it will be easier for you to find the third side. Okay, so with the theorem, we say that our hypotenuse squared is equal to opposite squared plus adjacent squared. So that is Pythagoras theorem. Okay, according to Pythagoras theorem, hypotenuse square is equal to opposite square plus adjacent square. Okay, so it means when you actually know your hypotenuse, or you know your opposite, or you know at least two sides of a right angle triangle, then it will be easier for you to find the third side. Okay, so looking at this diagram that we have over here, our hypotenuse is what? BC. Our hypotenuse is BC, so I will say BC squared over here must be equal to, what is the opposite over here? That is what? AB. So our AB squared over here plus our AC squared over here. Okay, so according to Pythagoras theorem, if you are taking this right angle triangle over here, then that is what we are going to have. Okay, so with this having been established, let's quickly look at these two questions over here. Okay, so let's try to solve these two questions that we have over here. Okay, find the length of BC in the diagrams below. Okay, so we have been given 4 centimeters over here. AC is 4 centimeters, AB is 3 centimeters, and our BC we don't know. But BC happens to be the hypotenuse. So according to Pythagoras theorem, our H hypotenuse squared is equal to opposite squared plus adjacent squared. Okay, and so our hypotenuse, which is what? BC, it hasn't been given. So BC squared will be equal to our opposite. Okay, so our opposite, let me just say, if this is our angle, okay, so let's say this is theta. Okay, so this is our angle, then it means our opposite square will be what? AB squared. So AB squared plus our adjacent square, which is what? AC squared. Okay, so we just find the what? The values of the, so our BC over here, BC squared will be equal to our AB. Our AB is what? 3. So 3 squared plus our 4 squared. Okay, and that is going to give us BC to be equal to 9 plus 16, which is 25. Okay, therefore our BC finding the square root of both sides, okay, will give us root of 25 here, which is going to give us 5 centimeters. So our BC is 5 centimeters. So that is the first one. Now let's look at this second diagram that we have over here. So this is I. Now let's look at II. Now when we look at II, so let me just say I put my theta over here. Okay, so I put my theta over here. We have been given hypotenuse, we have been given adjacent, we haven't been given the opposite. Our BC now is opposite. Okay, so our hypotenuse, so I will say our hypotenuse now is what? AB. So AB squared is equal to our opposite, then the opposite is what? AC. Our opposite is BC, rather BC. So BC squared plus our adjacent, which is AC, squared. Okay, so our AB we don't know. Our AB we know that is what? Our AB is what? 10. So that will be 10 squared is equal to BC, we don't know, and that is what we have been tasked to find. So BC squared plus our adjacent, which is C squared. Okay, so we are going to make our BC the subject. Okay, so we are going to have 100 is equal to BC BC squared plus 36. 100 is equal to BC squared plus 36. Subtracting 36 from both sides, therefore, our BC squared will be equal to 100 minus 36, which will give us 64. Therefore, our BC, finding the square root of both sides, our BC will be equal to root of 64, which will give us 8 centimeters. Okay, so this is how to use Pythagoras theorem to find the third sides when two sides of the right angle triangle are given. Okay, so when two sides of the right angle triangle are given, okay, so we use it to find our right angle, the third side of our right angle triangle. Okay, so that is about that. Now let's look at another important aspect of trigonometry, and that aspect we call it trigonometric ratios. Okay, I hope you have heard of sine theta, cos theta, and tan theta before, and that is what we are coming to look at over here. Okay, so trigonometric ratios over here, we have sine theta. Sine theta is opposite. Sine theta is opposite over hypotenuse. Opposite over hypotenuse. Okay, so opposite over hypotenuse. So when we take this diagram into consideration, our sine theta is going to be opposite over hypotenuse, and that will be what? AB. That is our opposite with respect to theta. AB is opposite, and our hypotenuse is what? BC. So that will be what? BC divided by what? BC. Now the second one here that we have, we call it cos theta, and cos theta is adjacent over hypotenuse. Adjacent over hypotenuse, and adjacent over hypotenuse is going to give us, looking at this right angle triangle over here, our adjacent is going to be what? AC. So that will be what? AC over hypotenuse, which is what? BC. Okay, so over hypotenuse, which is BC. And our tan theta is opposite. Tan theta is opposite over adjacent. Opposite over adjacent. And that is going to be tan theta opposite over adjacent. Then that is going to be opposite over adjacent. Opposite is AB, and adjacent is AC. So divided by what? AC. Very important over here. Okay, so we must take note of what this. It is very important. Okay, now for sine theta, we can shorten it and we say so. Okay, so sine theta can be shortened and it will be called what? So for easy recollection. Okay, so sine is equal to opposite over hypotenuse. Cos theta can also be shortened and we will call it what? Ka. Okay, so ka. Cos theta is equal to adjacent over what? Hypotenuse. And finally, tan theta can also be shortened. We will call it thua. Okay, thua means opposite over what? Adjacent. Okay, so tan theta is also what? Shortened to be called what? Thua. Okay, so tan is equal to opposite over adjacent. Okay, so let's take note of this, and as we what? Continue with this topic because it is very important. Okay, haven't established this, then let's quickly look at this diagram so that we will find sine theta, cos theta, and tan theta, and of course find the theta out of this. Okay, so our sine theta over here is going to be, let's see, taking this diagram into consideration, our hypotenuse definitely is going to be what? BC. Our opposite definitely is going to be what? AB. And our adjacent definitely is going to be what? AC. Okay, we know sine theta. Okay, because sine theta, we said that is what? Opposite over hypotenuse. Okay, so opposite over hypotenuse. And so our opposite is what? 4. Okay, our hypotenuse is what? 5. So our sin theta is going to be 4 divided by what? 5. 4 over 5. Our cos theta. So let's look at the cos theta. Cos theta is going to be adjacent over hypotenuse. And what is our adjacent over here in the diagram? Our adjacent is what? 3. 3. And our hypotenuse is 5. So our cos theta is going to be 3 over 5. Okay, then our tan theta, tan theta, tan theta is going to be opposite over adjacent. Opposite is what? 4, and our adjacent is 3. Okay, opposite is 4 and our adjacent is 3. Okay, so this haven't been done. This is sine theta. Sine theta is 4 over 3. Cos theta is 3 over 5. And tan theta is 4 over 3. Okay, taking this diagram into consideration. But how do we find our angle theta? Okay, so we can find our angle theta. How do we do that? Now, if you want to find your angle theta and you have sine theta, then it means you must find sine inverse of both sides. Now, if I find sine inverse of this, it will what? Clear or cancel the sine over here so that I will be left with what? Theta. If I'm using the cos, what I have to do is to find the the cos inverse of both sides. Okay, so the cos inverse will cancel the cos over here. Then I will be left with what? Theta, so that I will be able to find my angle theta. Okay, so what do I have over here? My sine inverse. Okay, so it is going, our theta will be what? Okay, so if I'm taking the first one over here, then it is going to give me theta is equal to sine inverse of 4 over 5. Okay, sine inverse of 4 over 5. And now you have to punch your calculator for sine inverse of 4 over 5. Okay, sine inverse of 4 over 5 is 53.13 degrees. Okay, so when you punch your calculator, that is what you are going to get. Okay, sine inverse of 4 over 5. I can also use this one that I have over here. Okay, if I'm using that, then I have to find cos inverse of both sides. Okay, so cos inverse, so I will get my theta to be equal to cos inverse of 3 over 5. Okay, now if you are using your calculator and you punch it correctly, then you are going to have 53.13 degrees. 53.13 degrees as well. Then the final one over here, if I'm going to use this one, then I must find the tan inverse of both sides. Okay, so if I find the tan inverse of here, it will cancel the tan, then I will be left with what? Theta. Then I will find the tan inverse of 4 over 3, and that is going to be tan inverse of 4 over 3. Okay, and that is going to be 53.13 degrees as well. Okay, so this is what we have for the first lesson. Thank you for your attention. For more videos, please subscribe to my YouTube channel for more of these videos. Thank you very much for your attention.